Hello, everyone. Welcome to another GRE Free Prep Hour. I am your host, Tyler Johnson, and I am an instructor and tutor here with Manhattan Prep, and it's nice to be hosting here once again. If you've never been to a free prep hour, the way this is going to work is I'm basically going to go heavy on a math topic for the next hour, and this session is happening live in a Zoom room right now. And if you want to attend one of those in the future, be sure to check the video description down below. We host these usually about once a month. I do one of these, but there's some other instructors doing their own as well. And if you're watching this online, it gets hosted up on YouTube a couple weeks after the live session happens. So do me a favor, if you're here in the chat room in Zoom right now, use that chat box and tell me what city you're connecting from. I'm out here in San Francisco, California, on the west coast of the United States. Got another West Coaster in Seattle. Welcome to you. We got a couple other shy people connecting from somewhere out there. That's okay. Boone, North Carolina. There we go. And DC, so a couple East Coasters. Good to have you here. The topic we're going to go over today is multivariable problems. So I'm going to start just kind of a quick problem involving systems of equations. And when I say system, that's basically referring to you've got multiple equations and we've got these two variables, x and y. So go ahead and try out this problem on your own. And when you have values for x and y, chat them to me. I'll give you a couple minutes. So I'd say there's kind of two basic ways to approach a multivariable system like this. The first and more straightforward way is something called substitution, where I'm going to take both my equations and just solve one of them out for a variable. So I have the variable on one side and all the other information on the other side. So I could take my second equation, rewrite that as x is equal to 2 plus y. And now I can take x in that first equation and replace it with the value that I know x is equivalent to. So from there, keep solving. You'll get your y value. Once you have that y value, you can plug that in to one of your earlier equations. and just replace y with the 3 that you know it's equivalent to. And then you've got your answers. You know that y is 3 and x is 5. And there's nothing necessarily wrong with substitution. It definitely works for systems like this. But generally, when I can, there's a method that I find to be a bit faster for the GRE. And that is something called stack and add or stack and subtract, depending on how you want to do it. The way this works is you basically line up the two equations and then either add or subtract them together. And you'll notice in their current forms, if I add them, because I have a plus y in the first equation and a minus y in the second, the y's instantly drop out. And right away, I get a value for x. And then from there, it's kind of the same as we saw in the previous strategy. You're just going to plug in that new value into one of the earlier equations and get your y value. So I do find it takes a little less time. There's fewer steps involved, and I'm just less likely to create some sort of simple algebraic mistake along the way. So when I can, I look for ways to stack and add. And note that there's a prerequisite here. If you don't notice the following, right? Like in order for stack and add to work, I need my variables to be of the same magnitude, right? I need it to be plus a single y and minus a single y. If I had like plus 2y and minus 4y, what I'd have to do then is you might have to scale the equations up or down until those coefficients match. That word coefficient, by the way, that just refers to the number in front of a variable. So for example, in this step, 2 is the coefficient. And before you stack and add, you need some matching coefficients because that's what ensures something's going to cancel out to 0 after you add or subtract them together. And that's the goal. You want something to just cancel out immediately. Okay, so now that you've seen a couple different techniques you can use on these systems, I want you all to try a problem that's a little more challenging. Check this out. Chat me your values for z when you're done. So for this problem, I think my preferred approach is to stack and add, but I've got some pre-work that I need to do first, because notice if I just tried to stack and add as is, that would leave me with 9x plus 6y plus 5z equals 23, which, I mean, it's still a true equation. The issue is that doesn't really help me towards my goal, right? My goal here is I'm trying to get the value of just one variable z. So I need to find a way to cancel out the x's and y's. So it's not just adding the two together as is. Instead, it's finding this connection. Notice you've got 3x plus 2y in the first equation and 6x plus 4y in the second. So that tells me if I take that second and divide both equations by 2, that's going to leave me with 3x plus 2y is equal to 6. And now things are looking much better. Because if I line everything up now, and I subtract, those first two variables are just going to drop out to 0. And the choice of whether to add or subtract, it's really just a personal preference. I could have just as easily multiplied, or I'm sorry, I could have divided both these sides by -2, and then added, negative 3x minus 2y equals -6. Whatever comes to you more naturally. Not a big difference in the end. In any case, you're going to be left with 5z there. On the right side of the equation, you have 11 minus 6. So if 5z equals 5, then you know z is equal to 1. So the whole point of this stack and add technique is that you're trying to get some variables to cancel out to 0. And in order to do that, you need to match up those coefficients. So either scale an equation up or down until those coefficients match. Once they do, just line them up and then add or subtract until they cancel out to 0. So we've seen a couple problems now where you've got these sort of algebraic systems. Another complexity you're going to see on the GRE is when you're given more of a word problem setup, right? Where the equations aren't given to you, but you have to write the equations yourself. So let me show you an example here. And I'm going to walk through this one with you. I'll go ahead and read it. And if I started to translate here, I might take that first sentence and write it as x plus y equals 12, right? I got a total of 12 apples and pears. And that's not necessarily wrong, but there's something that isn't ideal about my approach, right? What's something I could change about this equation to save myself from a potential headache later on? Well, the issue with x and y here is it's not really clear which one is apples and which one is pears. And if I get to the end of my solution and I have x equals something, I'm not going to be sure. Was that the apple amount or the pear amount? So what I recommend, get out of the habit of using x and y when you're translating word problems. Use something more intuitive. So if I say a plus p equals 12, now it's abundantly clear a is apples, p is pears. Okay, so I got my first sentence out of the way. And now I've got the second sentence where she bought 2 more apples than pears. And a common mistake I see here, someone's going to write 2 plus a equals p. Very easy to make that mistake. That is not a correct translation. And if I'm ever translating something and I'm not convinced I did it the right way, what I'll do is give myself a quick sanity check where I'm just going to insert a value like 1 or 10 or 100, depending on the scale, and make sure that my equation still makes sense. So I'll just say, okay, what if there were 10 apples? This equation would tell me 2 plus 10 equals p. So I would hypothetically have 10 apples and 12 pears. Does that match? No, it doesn't. I need more apples than pears. This gave me more pears than apples. So I know I must have reversed something. So now if I try and retranslate it, I'll throw that +2 on the other side. If I give myself another quick sanity check, just imagining hypothetically, if there were 10 apples, that would give me 8 pears. And that's what I need, 2 more apples than pears. So I've got the proper translation this time. And because this equation's already A in terms of P, I'm kind of primed for substitution already, right? I already solved an equation out in terms of a single variable, so I can just replace this initial A from the first equation with P +2, carry out the rest of the algebra, and I'll get that P is 5. Okay, so basics of translation. One thing that really helps me that I didn't mention here is when I'm looking to translate let me scratch that. Let me just show you another problem. Try this one out on your own and chat your answers when you're done. So the second sentence here, I think that's the more straightforward translation. You've got the total number of scarves and purses is going to be 55. So S plus P makes 55. And again, making sure I'm using S and P rather than X and Y to make it clear one is scarves and one is purses. And when you're translating, for the second sentence in particular, I think it's really useful. Locate the verb in the sentence. Usually that verb to be. So is, was, are, were. If you find that, that really indicates where the equal sign in your translation is going to go. So my number of scarves, S, is going to be 5 less, so minus 5, then twice the number of purses. So that's 2p minus 5, all anchored around that equal sign. And then notice my ultimate goal here. The question I'm asked is, how many scarves were sold that month? So as written, I don't want to replace S with 2p minus 5, because that's going to lead me to getting a value for p, but my goal is to get a value for S. So what I want to do instead is get things in terms of p, because p is the variable I want gone. I want to keep S intact to get that scarves number. So once I've got that first equation solved out for p, now I can replace the p in the second equation with its equivalent value. And then from there, just continue the algebra, and you'll get that S is 35. And that right here, it's more of the substitution approach. If you wanted to, you could take these two equations and line them up. And as written, if I subtracted here, it would get rid of my S's. Remember that S, I want to keep that intact. So really what I'd prefer to do is scale that first equation up by 2. It gets something more like 2S is equal to negative 2p plus 110. And now if you add everything together, you're going to get 3s. These p's will cancel. And then the solution's identical to these steps right here. And for this problem, I wouldn't say I don't know, both these take about the same amount of time in my opinion for this problem. So while I'm a fan of stack and add, I don't want to say there's anything wrong with substitution. Like my eyes are always looking to stack and add or stack and subtract when it's possible. But if you don't see it, substitution will work out in the end. One of the more challenging variants of word problems is something called an age or an exchange problem. So I want to show you all an example of one of those next. I'll give you 3 minutes, see if you can solve this one. So the first sentence here isn't so bad. Brioni is 7 years older than Chen, so B equals C plus 7. But the second sentence in blue, that's where a lot of people are going to get stuck here. And the most common mistake I see is people translating it as B plus 2 equals 2C. The issue with that is this phrase, in 2 years, that's going to be affecting both Brioni and Chen. And this equation right now, it tells me Brioni 2 years in the future is equal to 2 times Chen's current age, right? I haven't yet put Chen into the future. So here's my advice. When it comes to these age or exchange problems, the variables that you're assigning, so B by itself, C by itself, those represent the values in the present. When you move to the past or future, you have to modify all the variables involved in the problem. And the way I like to make that abundantly clear is I toss brackets around everything. So the proper translation is going to look like this, that Brioni's age 2 years in the future is twice Chen's age 2 years in the future. Right? I got to make sure I have a +2 on both Brioni and Chen because they are both 2 years in the future. Now that I have the proper translations, I'm going to substitute the fact that B is equal to C plus 7. And then from there, you're just going to continue the algebra. So I distributed that 2 across the parentheses. Now I'm going to start combining like terms. And you should get that Chen is 5 years old right now. But before you go selecting A5, make sure you identify the ultimate question we're being asked. We're looking for Chen's age 5 years from now. So Chen's 5 currently, they're going to be 10 5 years in the future. So for age problems, make sure you're defining everything simply. When you're in the present, just use the single variable B, single variable C. It's when you shift into the past or the future, that's when you want to toss parentheses and shift things to match the new information. Let me show you all one more of these age style problems. See if you can figure this one out. So my first sentence, that's the easier of the two, that Marisol is twice as old as Vikram right now in the present. For this second equation, it might help if you kind of rewrite it. Because remember, this 8 years ago phrase, I have to make sure that is being applied to both Marisol and Vikram. So I have Marisol's age 8 years ago. That's going to be m minus 8. Then I've got my equal sign here. So it was 6 less. It's going to be a minus 6. Then 3 times Vikram's age 8 years ago. So it's saying the same information as that blue sentence. I've just kind of reused that phrase 8 years ago to make it more clear that I need 3 times that entire expression v minus 8. It's not just 3 times v, it's 3 times Vikram's age 8 years in the past. Okay, once that is set up, go ahead and distribute that 3 across the parentheses. And I'm going to get something like this. You'll have 3v minus 30 on the right side. So m is equal to 3v minus 22. And now I can substitute. I know m is equivalent to 2v. So m is going to be equal to v, which means Vikram is 22 right now. The question is, how old is Marisol? Well, Marisol is double that. So your answer is 44. So key thing with these problems, it's not so much the present. It's when you're morphing into the past or future. That's the tricky part. And when you're doing that, make sure you're modifying both variables. So let me show you one more problem. This one's not an age problem. This is the exchange variant, where there's a trade that happens. But mechanically, it's a very similar process. Try out this one next. First sentence, Anke has 5 fewer candies than Conrad. So A is C minus 5. Second sentence, got to make sure you wrap things in parentheses when they change. So Anke is going to give Conrad 5 candies. So Anke is going to lose 5, Conrad's going to gain 5. And after that happens, the amount Conrad has is 4 times higher than the amount Anke has. So again, Conrad gets a plus 5, Anke gets a minus 5. And Conrad's amount is 4 times greater. Okay, and if I expand, or distribute rather, that 4 across the parentheses, here's where I'm at. And from here, recognize that I'm solving for the amount that Anke has. So rather than substitute out A, I want to preserve A and substitute out C. So rewrite that first equation. So it's all in terms of C. And now you can replace that C with A plus 5. And from here, it's just a matter of solving out for A. And you should get that A is 10. So your answer is B. Okay, so shifting gears, we're going to switch out of age problems here. There's another one I want to talk about. Take a look at this one. Give you around 3 minutes. Notice that our ultimate goal in this problem, how much more than an apple does a pear cost? So it's not just a single apple or a single pear, it's the difference between them that I'm trying to solve for. And if I translate my information, Jorge buys 4 of each for $3.20. Gina is going to get 6 apples and 2 pears for $2.40. And here, I think it would be kind of painful to solve either one of those out for a single variable. So what I'm leaning towards is that stack and add approach. But none of my coefficients match right now. So I'm going to have to scale one of those equations up or down. And for me, the intuitive move that comes first is multiplying that blue equation up by 2. So I'm going to get 12a and 4p makes 480. Now when I line it up, the 4p's are primed to cancel out if I subtract. So do the subtraction. You'll get negative 8a is negative 160. So a single apple must be 20 cents. Now to find the pear amount, I can plug that 20 cents in to this equation right here. Solve out for p, and I'll get 60 cents. So the difference between them is going to be 40 cents. And I know the answer is C. So good use of stack and subtract, but there's an even slicker way that I could solve this one. And I really want to note anytime I'm in this situation. If my goal is to solve for an expression, right? I'm not solving for a single p nor a single a. I'm looking for the entire expression p minus a. In cases like that, I can often solve directly for that expression. So going back to the original equations I had, I'm just going to rearrange them slightly so the p's are on the left. And notice, if I were to subtract these in their original form, what I'm going to get is 2p minus 2a, which is very, very close to what I'm trying to solve for, right? I found double what I'm solving for, so all I have to do now is cut everything in that equation in half. And in just 2 steps, I've got the answer. So keep that in mind. When solving for an expression, you can often solve directly for it. There's no need to find the individual values of p and a if I don't have to, right? I don't get any bonus points for knowing a single pear or a single apple. The goal here is to find the difference between them. And if I can do that more directly, I'm going to do that every time because it's going to save me some precious seconds that I can use elsewhere on the test. Okay, stepping away from word problems for a second. I want to show you kind of complex algebraic problem. Wrestle with this one, but I'll show you there's a trick I can use. You'll have about 3 minutes. So there's a way to solve this one using pure algebra, but I think that technique is pretty difficult. And what I'm going to advocate for instead is, well, on any quant problem, after you read the question stem, you should always take a peek at the answer choices to get a sense of, what is the answer going to look like? Get a sense of the range, get a sense of the format. Am I dealing with fractions or decimals? Is there exponential notation going on? And what I see here in the answer choices is that the variables x and y are present throughout. And that's going to open the door to something. So when there are variables in every answer, I can do something that I like to call pick for Vic, where VIC, Vic, that stands for variables in the choices. So the way this is going to work is I'm going to assign numbers to the values in the question stem. So in the stem, I've got x and y there, and I'm just going to say, well, what if I make x and y easy numbers to use? And there's nothing telling me x and y have to be unique or unequal. So to make my life easy, I'm just going to say, what if x and y were both equal to 1? And I replace x and y in every instance in that stem, and then evaluate it out, and I see I end up with 4. Now that 4 is going to be my target value. Once I have that target, I'm going to plug the same exact numbers that I picked into my answer choices. Ultimately, I'm looking for the answer choice that spits out a match for that target. So starting with A, if I plug in 1 for x and y, I get 0, not 4. So that one's eliminated. If I try it with B, I get 2, not what I'm looking for. Try it with C, also get 2, not what I'm looking for. Try it with D, and I get a 4, and that looks good. One of the downsides to this technique is you need to test every answer choice because you might get a false positive. Now, every elimination I make, right, all these eliminations, A, B, and C are for sure eliminated. But if E also spits out a 4, that means I now have to test some different values until I break the tie. But thankfully, in this case, when I test E, I don't get a 4. So E is eliminated, and I know the correct answer is D. So once again, at the start of the problem, peek at those answer choices. If every single answer choice has a variable present, you are greenlit to use this technique. Plug your own simple numbers into the stem. That's going to give you a target value. Then you plug the same numbers into the answer choices, looking for a match to the target. Okay, so let me show you all one more. It's another one of these where there's going to be variables in every answer choice. So see if you can apply that new technique here to get the correct answer. So I'm just going to pick my own values for m and n. And I know I can do that because there are variables present in every single answer choice. So let's say 2 pencils cost the same as 1 pen. Now each pencil costs 20 cents. And if 2 pencils cost the same as 1 pen, then I know 1 pen must be 40 cents. The question I'm asked is how many dollars does 10 pens cost if every pen is the same amount? So if 1 pen costs 40 cents, I just scale that up. 10 pens are going to cost $4. And at that point, I have my target. Trying to find which one of these answer choices also returns 4 when I insert 2 for m and 1 for n. And only one of these is going to work. The only one that returns 4 is going to be C, because I get 2 times 2 over 1. So I know that one is the correct answer. All those other ones are going to be off. And when I'm doing this, when I'm evaluating the answer choices, I'm only going so far until it's clear, right? I don't need to necessarily calculate the full exact answer. I can just see E over here. That's going to be in the hundreds. It's definitely not a viable answer. For D, I'm going to get a fraction, or actually I'm going to get 1, right? 2 over 2. So if I can just look at something and just tell it's not in the ballpark, just eliminate it. And the only one that's close, the only one that's exact is C. So that's how that technique works there. I had a question in the chat about units here. So just make sure the ultimate question is we're trying to find dollars. So I kind of saved myself a headache of having to do any unit conversion by just writing 20 cents as 0.2 and 40 cents as 0.4. So if they give you information in cents and they want you to answer in dollar form, just make sure you're converting the cents into dollars as one of your first steps. And generally, anytime there's a unit conversion involved, you want to make that conversion in your first step to avoid any trap answers later. Okay, so that just about does it. Before I let you all go here, I want to quickly recap some of the things we talked about today. So remember, when you've got multivariable systems, there's nothing wrong with substitution, but I do find stack and add or stack and subtract to be a little faster, a little easier mentally to process. So that's what I'm trying to do when I have multiple variables involved. And if I'm in a situation where I'm not solving for a single variable, but rather some expression that relates multiple variables, see if you can arrive directly at that expression. Because questions on the GRE, they're designed in a very specific way. Like everything is created to be solvable within about 2 minutes. And if you're solving for expressions, chances are there's a way to manipulate the other equations to get there directly. Another big thing here, get out of the habit of using X and Y for your variables. If it's a word problem, try and use the initial of whatever item you're working with, right? If it's apples and pears, A and P are way better choices than X and Y. And when we talked about age and exchange problems, right? The key there is define your variables in the present. And then when you're moving to the past or future, slap some parentheses around those variables and make sure you modify every variable, right? If you're 5 years in the future, you got to slap a +5 onto every variable. And finally, that last technique we talked about. Always glance at those answer choices before you start solving. If you see there's a variable in every single answer choice, then you're greenlit to use the pick for Vic approach, where you're just going to pick some simple numbers for the variables in the question stem. That'll produce your target value. Then you plug the same exact numbers into the answer choices, looking for an answer that matches that target. All right, that's it here. So I hope you all had some fun, got some good practice with multivariable problems. If you want to check out another free prep hour in the future, there's a link I'm going to drop in the chat box. If you're watching on YouTube, it should also be in the description of the video. And in addition to these free prep hours, we also have another free resource. That is, you can come to session 1 of our 9-week course. We open up session number 1 to the public. So if you want to check out a 3-hour experience for free, head to that link. And yeah, would love to see you at one of those in the future. So I'm going to go ahead and close out the room. Thank you all for being here. And yeah, check us out again sometime, whether it's another free prep hour or a free session 1. Take care.